periscope under ISAR project, and hot standby routing protocol for gigabit switches, TIFAC core and network engineering, TST funded, and grid scheduling algorithms, TIFAC core and network engineering. And sir has received more awards and achievements in his career, and very few of them are Best Paper Award at 5th SIRS 2019 of Springer Asian Conference in year of 2019, and also Mentor of Charge AIM in NITI IOT mentoring program and India, and jury judge global entrepreneur. Vadvani Foundation. It has been given by Vadvani Foundation USA, and guided 3 PhD theses, 5 ongoing PhD theses, and established MOUs with various universities and industries in abroad, including TUM Germany and Reliance Geogenesis, and so on. And sir has guided more than 3 students, and 3 students have completed their PhD, and currently it is ongoing with 4 students. And Shajulin Benedict graduated in 2001 from Manoanmaniam Sundaramar University, India, with a distinction. And in 2014, he received his ME degree in Digital Communication and Computer Networking from AKC Anna University, Chennai. He is university second rank holder for his master's. He did his PhD in the area of grid scheduling under Anna University, Chennai, and he was affiliated towards the same group and published more papers in international journals. After his PhD award, he joined a research team in Germany to propose postdoctoral under the guidance of Professor Genret. He served as a professor at SXCCE Research Center of Anna University, Chennai. Later, he visited TUM Germany for teaching cloud computing as guest professor of TUM Germany. Now he works at Indian Institute of Information Technology, Kottayam, Kerala, India, and Institute of National Importance of India. He serves as Director, PI, Representative Officer of AIC IIIT Kottayam, Secretary number 8 Company for Nourishing Young Entrepreneurs of India. His research interest includes HPC, cloud, grid scheduling, performance analysis of parallel applications, including exascale and cloud computing, IOT, blockchain, parallel compilers, and so forth. So with this note, I would like to welcome today's resource person, Dr. Shajulin Benedict, to hand over the session. We welcome you wholeheartedly, sir, and thank you so much for accepting our invitation for being the resource person for this ATAL sponsored FTP on IoT applications, paradigms, and principles. We welcome you, sir.
Good morning. Good morning to you as well as the HOD, madam, for a very great information, sharing the information about me. So today, basically, I will be talking about Internet of Things, especially the performance and monitoring aspects. So I have already, sir has given a brief detail about what I am. So I am not going to explain these things again. So the agenda today basically will be like this. Of course, few introduction of Internet of Things and general view of Internet of Things, then applications of Internet of Things were discussed in the previous lectures. Today, I will be covering about the, again, I will give a very short wrap of this Internet of Things, the trends, and then I will focus a little bit on this wearable computing with, again, a very basic level. And then I will talk to you the architectures that are there with more emphasis towards the serverless IoT architecture. Hope serverless architecture was not discussed earlier in the lectures. And with this, then I will dive into the monitoring aspects, like how the performance could be monitored, which is also another important domain of research that you could focus, and the tools that are there for monitoring the performance of such IoT applications will be the discussion. So this is the flow of the report that I'm handling today. And finally, I will also touch upon what kind of collaborations are possible, as well as what kind of funding options are available at our incubation centers. That will be like another last 5 minutes. So this is how the agenda of the talk will proceed. Of course, Internet of Things were continually discussed in the previous lectures, but still I would like to give a brief outline again. What is Internet of Things? It's an extension of Internet, right? People would have also talked about, and who are in this call, of course, you can easily understand what is Internet. And basically, Internet in the earlier days, it was just for computing devices, most typically like computers, sensor, computers, the servers, and so on, right? Also with mobile devices, but not to the things, right? Things in the sense it can be like your table, it can be your desk, it can be bulb, it can be fan. So these are things actually, and if you are extending the internet to the things, then it is Internet of Things. So how to extend? There are several ways. How to bring the sensors, how to provide some connection to actuators, that are all the discussions that comes under this Internet of Things, right? So future internet, basically it is expected that around billions of computing devices will be there, billions of personal devices will be there, and trillions of sensors or digitized objects will be there. And that's the reason entrepreneurs, business people, technical aspirants are moving ahead and trying to focus on this Internet of Things to develop products. And very recently, we are also planning to organize some activities like designing toys and enable internet to or extend internet to those toys, so that toys design will be another major trend in the near future. So future internet is expecting that almost all devices, almost all things should be connected, right? Technically, there are several challenges, but if you bring to that level, there are several ways where you can bring the society to a smarter level. I mean, the citizens will become smarter, right? So it's a very interesting story also, like in 2050s, we can expect more like, robots as well as the things or machines are going to communicate each other and drive the citizens, drive the people who are living in the society, right? It is also expected like, you can have some sort of helmets which will just pick up your signals from the brain, and it can activate whatever is required. For example, you have forgotten many things that you have done in the smaller ages, right? We all forget things, and that is the nature of human. And for example, in very short, very small, like fifth standard or eighth standard or 10th standard level, what we were doing, right? What we had achieved, or what we were very passionate about, right? How it has changed the trend, right? All this information are somehow lost, right? But it should not happen in the future. Therefore, there is an expectancy that you can wear some helmets, and these helmets will pick up the information that are there in the brain and that can process that information. And again, if you can load some other information to your brain through this smart helmet, you will be able to recollect certain things that are not available, or that are that may be that may be required for you in the future. So all these things are possible, and in 2050s, it is expected that large difference, large variation are possible in the world because of IoT. So it is also enabling you to create knowledge-driven society. Knowledge-driven society in the sense like be it a farm, be it an industry, be it an healthcare industry, or whatever domain you will be working on, all these that are connected in a society will be knowledge-driven. So the things are going to talk to each other. That's how you would have listened in most of the lectures in the previous cases also, right? For example, the fridge is going to talk to you. You are walking very near to a mall, and the mall, is some devices, some sensors over there are communicating to your handheld device and making some sort of bargain. And finally, the mobile device is highlighting to you, saying that, oh, you could have purchased this particular device. Maybe you are searching for a TV to purchase. Okay. and if you are searching for that TV, you reached some particular location, a mall, somewhere you are walking down the street and you immediately get a message from your mobile device saying that the TV price of the brand, particular brand, is very cheap in this particular mall, and the offer is only just for 1 hour or maybe another 2 hours are left. And if you can get it, then you will be saving around, say, 10,000 rupees, 20,000 rupees. That will be a good deal, right? So knowledge-driven society is possible using your using such IoT environments. And also, farmers are able to get information like when the yield will be high, when you want to go for check whether the ripe mangoes are ripe. Very recently, I also have seen like you can use your mobile device. You can take a picture on the mango tree or just capture the video of the mango tree, and you can start counting how many mangoes are there, right? How many jackfruits are there, right? How many hidden things are there, right? Similarly, in a very big shop, you don't know how many, say, let us say some rods. You want to count rods. There are n number of steel rods in that industry, and you just take a camera. From your mobile device, you just take a picture of that, and immediately it starts counting and it gives the number, right? If a human has to do it, may take more hours, but now it becomes very, very short time, and the benefit out of that is very high. Similarly, like in Tamil Nadu also, you could see like there are n number of different vegetation, plants, and so on. You may not know how many fruits are available in that particular agricultural farm. But if a drone is flying over the farm, it will just immediately count and say how many required vegetation is there, right? So these are all expectancy, knowledge-driven society. It is creating a knowledge-driven society which will really create a lot of developments in the future. Cognition-enabled machines are becoming popular, right? So the machines are going to talk each other. A plant, maybe a steel plant or a car manufacturing plant, which consists of several bodies. Like for example, a car plant, manufacturing plant may have several stages, right? One is the body construction, one maybe painting, and so on, so on. So many plants are required, and one machine or a sensor from a plant is communicating to the other machine of the plant, and it is saying, okay, now the job is about to get completed. You can start, or you can start to do some other work, right? Or you can invite some other work. So likewise, cognition-enabled machines are becoming more popular these days. Right. So this shows that n number of devices, n number of components are getting connected. Things are getting connected not only in home, offices, models, coffee shops, airport, gyms, and so on. And all are expected to bring the welfare of the human being, right? Of course, it would have been discussed what is the definition of Internet of Things, but I'm just going to touch upon what the Internet of Things mean. It is an extension of Internet. Very simple definition. It's an extension of Internet connectivity, not only to the normal devices which we were already using, like computers and mobile phones, but it is also to objects. It is also to the things that can provide the network. The trend is very high. This is very important that we want to understand. Internet of Things is going to play a major role, and it is still continually playing a major role. And there are n number of options that you can do with IoT. See, you can see, as according to a survey, it is like IoT is going to reach 200%. It is at 200% growth compared to the other one, because it is combining many other technologies together to bring the profit and revenue in the future. So if you can devise your research, if you can devise your product development according to Internet of Things domain, there are high possibility that you can succeed in the trend, or you can lead the trend. Of course, it can be mixed in several domains. According to Deloitte NASCOM report, it is told that it can be applied in several sectors, and the growth base of the IoT trend is very clearly pointed out here, that it is applicable for agricultural, several applications you can think of, like yield calculations, checking the ripeness of mangoes, checking the ripeness of apple, checking the ripeness of banana trees, just by flying the drones, capturing some images, and from there the image processing could be done using several analytics, like deep learning algorithms could be applied, or there are nowadays several good platforms like TensorFlow is there. You can use them and you can do the analytics, and you can make the actuation to happen easily. So agriculture is a very good sector that you can target, because all these sectors with IoT is going to be a very important trend in the near future. Not only in India, but also in abroad. India is playing a major role in IoT because of the growth that is required. The society needs that, right? Because we see the problems from the society. There are n number of problems in the society. If you can identify those problems, and if you can find which solution could be applied, there are possibilities that we can apply IoT. So far, still we don't have solution to say when our bus will reach our bus stop, right? Still we don't have solution to say when to inform the auto remotely, so that the auto or the cab will reach the location on time, right? And, of course, there are several hidden factors like transportation issues are there and so on, but how the solution could be addressed, which IoT sensors could be applied there, right? All these are going to be a major turning point, because if we target the societal problems, there are a number of opportunities, and the products that we develop out of that will be very, very good. So you can see, like agriculture is there, retail is there, healthcare. There are so many applications relating to healthcare. Of course, a few of them would have been addressed in the previous lectures. I would like to highlight one of those, like, of course, patient monitoring is always there, right? But very recently, people also started to understand the human emotions while you sleep, right? Because when you sleep, you don't know how you sleep and when you wake up, right? What makes you to wake up, and what are the difficulties that happens when you sleep, right? Especially when you are a diabetic patient, right? A diabetic patient, if he is having the sugar level very low, it reaches 40, maybe a very little sweat only happens. There is no sort of difference in his movement or something, and then it is going to create a problem if someone is not noting that, right? It can reach 20, and then there is a critical stage for him, right? So if the camera assisted solution is there, when he starts to sweat, if some sort of facial changes happen in his behavior, or if his emotions are not proper, based on that can we assist him with the appropriate information. So these are all some sort of very recent topics that are happening in the current trend. Also in automotive industries, like you want to create, or you want to establish a new car, right? You want to purchase a new car. So far, we are just going to the companies, and we are selecting which model they want. But there are also scenarios that is going to create a breakthrough where you could select the design. such a way, or you can draw the design and it can reach the technical team of the company through the assistance of blockchain technologies. And based on that, the technical assistance will, technical committee of that particular company will say yes. And if not, with some other suggestions, and accordingly, the car manufacturing is immediately done with 3D printers. So 3D printers are built such that you can immediately create the car, you can develop the car, right? And it is sold, it is given to you automatically, where the banking sectors are also connected together. So it's an IoT cloud and blockchain technology combined together, where automotive industries are getting more popular. And also recent trend is creating shared mobility concepts where transport and logistics are taken care. Shared mobility is becoming very popular with the help of the IoT technology, which means already we are practicing shared mobility, but during COVID period, how many number of people should enter into the vehicle? How many should not enter into the vehicle? All this can be softly done with the programmatic approach, along with IoT sensors and technologies. So the trend is very high. It is also international level, globally. If you see, also you can notice that the trend of IoT is very high. So which platforms are providing such kind of IoT trend? There are several platforms. Almost most of the cloud platforms, okay, cloud platforms in the sense, whoever were offering cloud technology, whoever were providing cloud infrastructure, have moved to IoT. They also started to support IoT along with their infrastructures. So very notable cloud infrastructure providers, if you see, in cloud we have infrastructure as a service, platform as a service, and software as a service models, right? And there are very leading players like Amazon, Google, then Microsoft, and so on, with their own platforms. But all these leading cloud players, cloud platform players, they have moved to cloud. They not moved entirely, but they have the support for cloud, and they have still been playing a major role as a platform provider. Say, for example, Microsoft, along with Azure, they combined and brought IoT suite. Microsoft IoT, Azure IoT suite, which is considered to be like 29% of utility there compared to the other platforms. Whereas Google, they have Google Compute Engine as infrastructure providers, but now with IoT support, they have Google Cloud IoT, which is now having a major breakthrough there. And Amazon, which was initially started as a bookseller, online bookseller, now later they became very popular in cloud, which were like a leader in cloud. And although now it is having like in the top rank, you can notice that it is having IoT also. Although they have major support with infrastructure as a service, now they also have very good support for IoT. Not only just IoT suite, now you can see there are support for green grass and so on. So these are all different platforms that the companies are offering. Since big players are involved in such developments, you can expect, you can easily view that the technology is moving very far, and we have to keep based on that. And with wearables and so on, the patient health and so on, there are a number of options that we are thinking of in the near future. So apart from normal big players, there are also several other platforms that are available for IoT, like Blue Pillar, Salesforce IoT, Cloud Array, and so on. These are all some popular, still popular platforms which people are using for IoT. Yeah, so I would now touch upon the subsets of IoT domain. I am not sure whether these subsets were discussed in the previous lectures, but I will give a brief of this subsets of IoT, a subdivision like types of IoT. So we have a very brief knowledge on IoT. Now we are going to see the different types of IoT, how they are broadly classified: industrial IoT, consumer IoT, social IoT, IoT, productization IoT. These are five major subsets of IoT domain. Industrial IoT is very popular for industrial sector, right? For industries like car manufacturing, then some product development, mass level, industrial level product development, and so on. Consumer IoT and so on. We will discuss about these subdomains in detail now. Industrial IoT basically applies embedded intelligence and network connectivity to improve the processes that are involved in the product development. So it is basically a normal process that are happening in an industry will be modified with the assistance of IoT, so that the technology, the industrial development goes really in a better way, right? It introduces smart design principles. That's the major thing. Several industrial sectors are involved, like for example, car manufacturing, 3D printing, energy industry, healthcare, manufacturing, smart buildings, and so on. Smart buildings, you want to construct a building you want to support, you want to see what is the status of that building. Like for example, how many energy was utilized, what is the air quality of that concerned room, right? What is the water quality of that concerned room? For all these things, you can use sensors, you can apply sensor. Industrial IoT, it is following a standard like Industry 4.0. It is a term that is becoming very popular in Europe. Industry 4.0 is also termed as Industrial IoT in the USA. So the technology is same, but the naming that was given in Europe was Industry 4.0, and in the USA it is Industrial Internet, okay, or Industrial IoT. Industry 4.0 is, some people pronounce it as 4.0, but I believe that it should be 4.0 because version 1, version 2, version 3, like that version 4, Industry 4.0 is there, which talks about the industrial revolution, right? The revolution that created in the industry to improve the process, to improve the profit that comes out of the process that are involved. So initially, in the first revolution, if you see, water and steam power engines were used, and because of that, the way how the development happened in the industries changed a lot. And then the second revolution happened when they introduced electrical engines, power, and so on, where, for example, belt conveyors were powered by electricity. So when you use such kind of electrical engines or power engines, the process, the way how they wanted to transfer the goods from one place to other was made almost automatized. So because of that, the process got major development, and that is considered as second revolution. The third revolution was because of electronics and IT. Like you can even send email, you can send some sort of like ordering things, purchasing things online. So all these are IT and electronic based. Still, the automation and the decision making is not there with the 19th century, the third revolution, industrial revolution. Of course, the thing became the way how the processes were done differed. And because of that, the speedy evolution happened. Like instead of sending normal post, they did emails and they validated that. So all these are the revolution that is considered for the growth of the industry. But now it is about the fourth industrial revolution, which is no IoT control, like sensors are controlling it. Machines are talking to the next machine, right? So because of this, the process that are involved in the industry for the growth of the industry has changed, tremendously changed. It is not happening immediately. Like Siemens has collected several information and they had to go through that evaluations and finally they understood, yeah, some sort of requirement based on IoT is required. Like you can see, they have collected more than 40 manufacturers from around 11 countries. They started to understand what are their requirement, how it can be changed, how the processes could be changed so that the industry, some sort of revolution could happen. Thus, the industry 4.0 evolved. Like, very simple example with the help of wearable devices. If you see, labels are monitored. Labels are monitored, right? For example, you can wear, you can provide a wristwatch on the laborers. Maybe it is a chemical factory, and the heartbeat of him, the level of his work, how fast he is working, all this information could be monitored. And not only that, the machine can automatically send messages so that the other machine and the other unit is ready for something. Right? Let us see some of the examples. Like for example, predictive maintenance. Right? Machines are predicted like when it is going to fail. Let us take an example of car repair, or you want to go to a workshop. You all know that every some particular period you need to do wheel balancing, you need to change the tires, you want to check whether brake oil is there, whether the condition of the vehicle is good. So all these things you have to do automatically, right? But so far what is happening, people check the tires. If it is okay, they keep running, right? Or suddenly if something happens to the tire, when it gets punctured or when it becomes totally damaged, they search for the workshop. And especially for expensive cars, like for example BMW or some other cars, you may not find appropriate workshops every places, right? And the spares for that particular car is not immediately available, right? So if some sort of sensor is available on the tires, and if it is immediately notifying the concerned workshop, like the tire is about to get flattened, so you have to now replace with a new tire. So immediately the information goes to the workshop concerned workshop of this particular car can start bargaining. So there can be a sensor there, some device can be placed there, and this particular device can keep searching on the market, and it can find the very lowest, the best, not lowest, but the best and the cheapest solution where the tire is available, and it can make the order automatically. And from there, the tire can reach the workshop, and the estimated time of how much time you want to spend in the workshop, and everything can be given to the particular person, so that now he is able to automatically do the maintenance. Right. So all these are important solutions for industries. Like customers get it in affordable price, industries can manage this production at high scale, right? So Industry 4.0 basically promises the small as well as medium enterprises in succeeding in competitions to increase the productivity. You can get more productivity, increase the revenue, you can optimize the manufacturing processes. All these technologies can be supported with appropriate sensors with different technologies. And the delivery of customer service is very good, right? If you would have watched the video of Jack Ma, right, very leading Chinese industrial, business magnate we could call, right? So this particular guy always says that provide service to the interior or the rural locations, right, in an automated fashion. So if a solution is developed that will reach the interior locations of the rural locations of the society um, in a reachable manner, then you will become the very big business person, right? So the processes that are happening with Industry 4.0 is aiming for that purpose, right? So sitting in a very rural location with the help of just internet and the things connected together, you can create a very big knowledgeable society in the near future. So if you see the building blocks of such Industry 4.0, you can notice that not only the processes that are there in industry is involved, big data is involved, robots are involved, some sort of simulations are involved. For example, the machines can make some sort of simulations like what will happen if I go for purchasing something, what will happen if I am replacing a particular spare part with some other spare part, right? Instead of a particular branded tire, if I modify with another branded tire, what will be the health status of the car, right? So then integrating the devices like horizontal or vertical integration, Internet of Things, cyber security, cloud computing, edge computing, fog computing, many technologies are involved, augmented reality, and so on, like additive manufacturing. You can even do a 3D printing for prototype, and you can see what will be the model of the outcome of the industrial product. Likewise, you can do a number of things in industrial IoT. The second type of IoT is consumer IoT, which very popularly everyone used to discuss, like the wearable devices. Most predominantly it is applied for healthcare and similar kind of applications. Also for the welfare of the particular person, like voice assistance, right? For example, and there are examples like ORIA is there, and wallets are there. So these are some voice assistant solutions, like voice assistant solutions. You can call and talk, and then it will answer to you, right? So far there are no solutions where the researchers know they want to write an article, but they don't know which article or which article should be referred, right? If there is a voice assistant, like if I take my mobile and if I say, I need a set of best articles, top 10 or top 50 articles that cover this particular title. So just you are giving a title name, and it is immediately searching some best article based on different constraints, based on different parameters. It is suggesting you some articles. So far there are no solutions, right? These are all voice assistants help for us, right? Similarly, everyone will be, of course, our academic people. We are all academic people. We all would be interested in writing books, right? But writing is always tough. Typing is always tough. But speaking is much popular. Comparatively easier to many of us, right? As like we teach the class, right? So if there are voice assistants that are just recording what you are reading, what you are saying, and that is converting that into a textbook, you would have completed at least 5 or 10 books now, right, in your career. But such assistants are not there. But can IoT provide? Yes, it is possible to provide. Our wearable computing devices, consumer IoT subdomain is targeting that. Similarly, the utensils like wallets. Wallets with RFID is nowadays are available in the market. So RFID, even if you lose anything, it can even record where it has gone. You can monitor where it is there and trace that. School bags are nowadays coming with RFIDs, right? One of the school student did a project at the IIT Kottayam under Nidhi Aayog, and she did very good development with that RFID based for school bags. So it immediately reports to the police and so on. So practically, of course, concept-wise, if you see, oh, it's very simple. But product-wise, if it is not available, you have to be the first to develop that. So consumer IoT is talking about that. It is talking about even fashion items like you can wear a dress. Typically, if it is very hot, it has to cool. If it is very cold, it has to become hot. So, for example, especially in colder regions like Canada or Germany or some Australia in some winter periods, or also in Jammu and Kashmir or some states of India, if it is very cold, people find discomfort to go outside. They had to wear lot of blankets and so on, right? So instead, if a dress is there, which is IoT actuator based, it is enabled with some automated temperature control, which heats up your body and it warms and it always maintains the temperature of 25 degree. So it's a best solution, right? So only one dress, it is providing you the comfort that you want. So these are all wearable devices that are available in the market. The popular wearable applications in healthcare is definitely creating important turning point, some applications like weight control, how you do the exercise, how you care the diabetic patients, how you care the stroke patients, how you do the athlete thing. So, are there any monitoring systems like textiles that warm up during chilly days? So all these are some of the examples. Like you can check the Polar Seal. It's a company which is offering such textile dress that will monitor the temperature of your dress and it will keep you always with some particular temperature. So wearable devices are tremendous, and all these comes under the subheading consumer IoT, right? So a smartphone or a mobile device will be able to collect the information and show you the statistics of what is there and what you will have to do. Social IoT is another type of IoT where it senses the societal informations from the medias like Facebook, Google, plus LinkedIn, and so on, and it indicates to you how better or how appropriate you could behave in the future, right? This becomes more popular and important tool for politicians as well as some public people, public figures. The reason because you maybe would have sent a tweet, and that particular tweet, you don't know how many different sector of the nation or a big global market is reacting to that. So if a sort of robots, right, are sensing all these behaviors, and if it is commenting to the person how it has behaved, then due to that, you could change the the messages, or you could be appropriate so that you again regain the popularity among your people. Similarly, semantic IoT. Semantic IoT is more tailored to some particular topic. Like for example, if you want to understand the likes of a particular message from a particular political person, right? It is contextualized or personalized to some particular theme. Of course, it is also more similar to social IoT, but it is more tailored to some particular solution. The last one, which is productization IoT, it is more towards 3D printing and solutions similar to that, where the customization of the development are happening. The productization, it has to automatize the entire product development with the help of 3D printers or some other fab related, fabricating related machinery. So all are machine connected, and the decision making are also done through machines. So having said all these different types, now I am jumping to the architectures. In general, IoT architectures are divided into three categories: sensors, actuators, as well as network devices. So sensors are going to sense, actuators are going to provide some sort of action, whereas network devices could be cloud, edge, fog, or something, and they are distributed devices which are going to give some um, suggestions or analytics. So likewise, you can see, some wearable devices here, and some network devices are here, and also you can see some actuation. So actuation could also be a wearable one. Like for example, heating up the textile, right? The dress that you wear needs to be heated up. So that is like an actuation, right? Some sensors are sensing from the wearable, then it is given to the network devices like mobile phone, cloud, and so on. And after that, some decisions are taken there. And based on the decisions, it is given to the actuator, which will be there again in this end. And it is again a kind of wearable or something like that. If we are targeting wearable device, if we are targeting industrial devices, then it will be machines, right? Normal industrial machines. If you are targeting social IoT, it could be the societal messages, right? Actuations may be a sort of message that is coming out of the inference. So all these are, or some examples would be alarms. They are all some actuations in social IoT. So likewise, here I am targeting this consumer IoT. In consumer IoT, more specifically in wearable computing, if sensors and actuators are there, right, the network devices are here. Got it? So sensor, actuator, and in between you have network devices. So I need not discuss more about the sensors. Of course, you all know it is about the sensing of the properties, right? Light sensor, touch sensor, humidity sensor, temperature sensor, force sensor, water flow sensor, position sensor, speed sensor, soil moisture sensor, ultrasonic sensor. Several such sensors are there. They are meant for different applications. Okay. For more specific towards wearables, if you see accelerometer are there to check the oscillation, the speed. Okay, gyroscopes are there to measure the angular movements. Likewise, global positioning system, heart rate sensors, pedometers, and so on. So all these are more specific to wearable devices. And actuators, they are devices just to do some sort of actions, right? So it can be dependent on electrical signal or air pressure or magnetic or something like that. So depending on that, actuators could be of 5 types. Hydraulic actuators, that means based on hydraulic power, some mechanical action happens. Pneumatic actuators are actuators that are happening because of some air pressure. Electric actuators are actuators that make some actions because of some electrical power. Thermal or magnetic actuator or because of some thermal action or magnetic actions. Okay. Because of those energies, some action, some mechanical action would happen, right? Mechanical actuators are some actuators where you use some mechanical motion, and because of that, the mechanical action happens. So some of the examples that you can see here in the pictures also I have mentioned, right? So basically IoT architecture in a generic perspective, you see you have sensor, you have actuator, and you have some network devices which will take care of the analytics and so on, right? So now I am going to introduce to you serverless IoT architecture, which is very recent IoT architecture where instead of executing your applications on servers, we are now going to do the same, of course, on servers, but without registering, without dedicatedly running the applications on servers. That is called serverless. So what, broadly speaking, what is serverless means? A serverless is a execution, cloud execution model actually, okay, where you are not reserving the resource. You are not fixing the resource, because in cloud we all know that it is a pay-as-you-go model. Pay-as-you-go model means for whatever resource you are using, all these things you want to pay, right? So assume that you have created one IoT architecture, okay, IoT application. You have created one IoT application, and this particular IoT application is monitoring, say, your temperature, or some sensors are sensing the temperatures every now and then, like periodically it is sending every 2 weeks once, assume like that. Every 2 weeks once you are collecting the information of a particular patient, or maybe let us say every week. Weekly once it is collecting the information from the particular patient, or it is collecting from the agricultural farm, whether the mango became ripe or not. It is collecting that information, and the processing is done in the cloud. So let us say that the cloud, since it is an IoT application, the cloud server should be powered on all the time. So every week, throughout the year, it has to be powered on. So imagine a VM or a cloud instance, if it is powered on the whole period of the particular application, the cost that it would take may be comparatively high. Although the cost of cloud is less than purchasing a normal machine, right? That everyone will agree, because if you want to purchase a server, it will cost at least 3 to 11 lakhs. But you are getting that in a cheaper price in cloud, right? Because cloud is pay-as-you-go model. So according to this IoT application, where you want to monitor the sensor, I mean, you want to monitor an agricultural farm every week, right? Every week you are monitoring. So you will have to power on that cloud instance continually. But the utility is very less. Like every week, only once you are going to collect the sensor value, right? So in that case, normal cloud system, normal network system, which I was mentioning, will not work. I mean, it will work, but you will spend more money. Rather, if you go for serverless IoT architecture, which I have told that the server is not running. Okay, initially it will not run, but once when the sensor is sending the information, based on the demand, it will start the server, and in that server it will start to run that application. So the state of the previous one is already there, and the server where it has to run or how it has to run will be allotted by the cloud provider. So AWS is not going to charge for the entire period of, say, if you are running for 1 year, it will not charge for the entire year, but it is going to charge just for the periods whenever it is becoming active. So every week, only once, some signal is collected from the sensor, and once when the sensor data reaches the storage device of the Amazon, the trigger of the information, triggering will happen such that it starts to search a server where it can run that application. So maybe it want to count the the number. So now it will just search for the server. It will power on the server. It will run that application. It will compute the application. It will store back the data to the storage device, and again the server is vanished. So that is called serverless. So it is serverless function which you can adopt in all levels, basically, not only in sensor, actuator level. In all levels of network devices. So sensors and actuators basically are just collecting information and providing actions, right? From there, the information goes to some network devices. Network devices could be cloud or fog or edge, right? I am not going to talk in detail about the differences between all those network devices, but in all these cloud, fog, or edge services which a cloud provider can provide, right? You can adopt serverless environment so that you are not using the resource all the time, only weekly once or very feeble time you are going to use. By this, the cost of the device, cost of the entire application of IoT is going to be less. Got it? So that is the serverless IoT architecture, and the functions are executed at all these levels as a form of containers. And there are several platforms that are providing this. Okay, like for example, kubeless functions are there, iron functions, fission, FN platform. All these platforms are available, which is working as open source, and you can use them under this Kubernetes platform. Okay. IBM Apache, they have implemented this OpenWhisk functions. So if you search OpenWhisk function, you can notice that you can use them as serverless functions. Of course, who will be the provider? IBM Cloud will be the provider in that case, right? AWS is offering AWS Lambda and Sparta. Okay, so AWS means, of course, you have to use AWS Cloud provider. Okay, for implementing such serverless functions. But why do we go for this? Because no, we want to reduce the costs that are involved in your IoT application, right? We want to see the better performance, and also we have to reduce the cost of the executions, right? So instead of powering on all the time and paying unnecessarily for the AWS, right? For what you have not used. Of course, you want to use. You cannot say, I cannot run the application, right? You want to run your IoT application, but the frequency of collecting data from the sensor is very less. Like every week, only once, or maybe monthly once, you want to collect the data. If you are not using serverless environment, you will have to pay for all the period that you are using, right? AWS Lambda is there. That is supporting AWS. Google Cloud Provider is providing Google Cloud Functions. Okay, Google Cloud Functions are there. Microsoft is providing Microsoft Azure Functions. Likewise, every cloud providers have started to provide such functions. Now comes the performance problems. There are problems where no researchers, as a researcher, we always see where are the problems, right? How to address those problems. Of course, there are a number of solutions, a number of ways how to address the problems, but no, we want to identify the problems, and one among is the performance issue, right? Performance issue of focusing towards serverless functions. There are several of those. You can see, like I have classified them as memory mapping issue, security concern, memory size issue, language standard issue, non-availability issue, cold start as well as warm start issue. So there are a few issues that we have to target, that a researcher can focus on, like mapping issue. Sometimes your serverless function will not fit with some IoT sensors. Okay, your IoT sensor may not be compatible with that functions. Say for example, Amazon lambda functions may not fit properly to your sensors, then that is a mapping issue. Or sometimes the memory may not be available, network may not be available, container may not be available, because we are saying it is a sensor serverless function, right? So that means your server is not running, but your application is hidden and it is live. And only when the event is triggered, like when the sensor is sensing something and it is dropping the information on the storage device of the cloud provider, that is triggering an event, and that now it is searching for the server, right? Now it is searching for the cloud instance. And at that time, if memory of that server is not there, or the container is not able to provide that cloud instance, or the network is not up, like for example, IP address is not readily available, then your serverless function will fail, right? So non-availability is another issue. Or there is a concept like cold start, warm start. Cold start means once when the event is triggered, the VM or the cloud instance now starts from scratch. Like it has to power on, it has to boot up, and then the application should be loaded. The required library and binary should be loaded, and after that the signal, the sensor data is or the sensor application is offloaded to this cloud instance, and then it is running. So this is like cold start. Whereas warm start means the already powered on VM or already powered on cloud instance will be collected, and there the application will be hosted and it will start to run. As you can imagine, warm start means the overhead should be less, whereas cold start means the overhead will be high, because you want to start the cloud instance from scratch. The next performance issue, if you see, like memory size problem will be there. Normally serverless, to run serverless functions, they limit the size of memory. Like for example, 128 MB to 3008 MB will be free for functions according to AWS. So like that, some cloud providers limit their size, memory size. So because of that, some applications may not perform well, might not perform well, right? Security standards are there. So how do you monitor? How do you, evaluate that? You can use a tracing approach or sandboxing approach or prediction approach or language increment approach. Of course, these are all different approaches where you can monitor how the performance of the serverless functions are behaving. For example, modeling approach means you use some parameters to sense and model the entire scenario of how the serverless function will be starting and what will happen, whether the serverless function will be able to fetch the new server for executing the application, like that. Or you can use some instrumentation, like you can insert some functions in between the serverless program itself, and you can see what happens, how is the performance of the serverless function is behaving. So accordingly, if you see, there are several tools, performance analysis tools, that are available on market. Of course, it is dependent on different infrastructure providers. Like Google have their own way of evaluating the performance of serverless functions. Azure has their own, VMware has their own, and Amazon, they have their own, and so on. So here you could see a set of performance analysis tools that are used for monitoring the performance of such IoT serverless applications. Like for example, Amazon X-Ray. Although it is not more specific to the functional level monitoring of functions, I mean the serverless functions, it is able to monitor the entire application. What is the health status of that entire application? Google has Stack Driver. Windows have application insights. Prometheus is very commonly used as open source one. CloudWatch, Amazon has also CloudWatch. Then Microsoft also has AppDynamics. VMware has Wavefront, and a separate company called Epsecond, they have uniquely developed one tool that fits for some open source serverless functions. So depending on whether they are commercial, whether they are open source, whether they are free trial, right? Are they measuring based on logs? Are they measuring based on plugins? Are they measuring based on a tracing approach? Are they using like a library so that you can use that, combine that library along with your application? Are they based on daemons, like an agent or like a daemon which will run and it will continually monitor what is happening in the serverless function? Are they a sort of service, like you have to run the service and it will start fetching the information from the serverless functions? Are they monitoring function? Are they monitoring the entire task? Are they monitoring applications as a whole, right? So depending on that, I have classified the list of available tools and I have marked here. So for example, commercial, most of them are commercial, right? Like, so you have to pay and you have to get them. Because they are proprietary ones. Of course, some free trial versions are available. Open source, it's very rare, right? Some are depending on logs. Like once when some issue is there, the log will be generated, right, in any software. So from that log, it will trace and it will find what are the performance problems, how it can be addressed, and so on, right? So that is log based. Plugins are available where you can use that plugin. You can combine that plugin along with your application, and then you can start the application so that this plugin will have a way to fetch the performance metrics, and it can show you what is happening there. Tracing is like a way where the entire information will be collected in a sort of file format, and then once after the application is complete, or once periodically, like every 1 month or 2 month once, this particular tool can go through the traces, the files that are available, and from the traces it will start to show what happened to your serverless function. So some tools like Amazon X-Ray, so they just go through these traces, finds what problem was there, why the serverless function didn't start really, right? Is it because of warm start problem, right? Or sorry, cold start problem? Is it because the memory of that particular cloud provider was not assigned properly? So like this, so tracing is done, right? So depending on different such categories, you can see that we have classified all these functions. So there are still several challenges that you could also address, like since serverless functions are often short-lived, how can you quickly find a better server, right? So serverless function needs to be executed, and where and which server could be checked, or which can be allotted. Whether the tools are facing vendor lock-in problem. Yes, several of these tools are proprietary ones, so they can the tool can simply show some wrong results also, where no one can really evaluate that, right? So it's a lock-in. So it's a proprietary one, and therefore you cannot do much on that. The other one is integration issues. Like if you would have developed a tool that will monitor the performance of all these serverless functions of an IoT application, whether it will fit to the cloud provider, right? If it fits to Amazon, whether it will fit to Google. If it fits to Google, whether it will fit to Microsoft Azure. These are all different issues. Even if now you could monitor some of the parameters, monitoring energy consumption of that will be very, very tough, right? Because it is it is not completely dedicatedly given to you. The server is not given to you. So all these are performance issues, performance monitoring tools are also discussed. So altogether, what I have done is initially I started with what is IoT, the trend of IoT and so on. And then I discussed that different types of IoT are there, and briefly I explained about different types of IoT. And after that I explained with several examples I have explained, and after that I explained the generic architecture of IoT, and I started to discuss about the serverless IoT environment. In serverless IoT, there are several issues, which is also common to normal IoTs, but the serverless is, since it is more recent topic, I was focusing on that. And there are several performance issues and how it can be addressed, what kind of tools are there, what kind of research issues are there that were discussed in the previous slides. Okay, so now I will focus a little bit, I think for another 5 minutes, I will talk a little bit about the incubation centers that are there with us, where you can also target to write something, propose something, so that you and your institute as well as your students would be benefited. Like for example, we have this MSME Business Incubation Center, where if you are submitting an idea and if the idea is approved, then each idea you can you will be eligible to attract 15 lakhs. Okay, so our incubation center at IIIT Kottayam is eligible to support 10 business ideas per year. So all of you are invited to submit ideas. You can contact me and I can provide you some support for submitting ideas. And once if you submit and if it is approved by the committees, each idea you can get to 15 lakhs approved ideas. Okay. Then we also have this AIC IIIT Kottayam, which is more focused on startups. Like for example, if your students are interested in developing some sort of IoT product, IoT systems or IoT related thing, I recommend you to apply to us. Since it is a startup, there will be a minimal fee also for that. Okay, incubation, we process that like an incubation system. But the network is very big. You all know about ATAL Innovation Mission. So according to them, we have a very good network, and therefore the startup will be promoted to get funding through our investors. And we also have established very good international tie-ups. One among is an international tie-up with Austria, and another one is an international tie-up with Germany. Okay, these two tie-ups are especially for startups, where the startups can go to these countries from our incubation centers. So if you have reached us and if you are willing to go to such countries for further developments, the provisions are open to you. Of course, for all these things, depending on the synergies and trends, some are merit, some are with pay, and so on, like that. Options are there. Okay. And then I would also like to inform you about the postdoctoral fellowships and two very recent activities that I personally organize. One is a symposium on ACM IEEE CSI Research and Industries Symposium on IoT. I recommend you all to forward this to your students. Prices of like rupees 10,000, 5,000 are there. Selected papers, if it is really worthy, we can consider it to special issue. And apart from that, if you are a researcher in IoT and if you have some commendable work, I highly recommend you to submit your work to the special issue, which is also very near. Okay. Like I think it is the end of May. or April, I think. So just check in the website and you can apply. So there are several possible collaborations like joint product development, joint organization of events, joint marketing. We also called for nodal centers. Every institutes can participate for nodal center of AIC to Play Pattaya. So additionally, joint editorial and joint book publications. I'm open for things like that. Of course, it depends on how we can interactively work, right? So with this, I thank the organizers and I am open for discussions.
Thank you, sir. So, dear participants, if you have any queries in this particular session, you can post a queries in the chat box. If not, you have a provision to unmute yourself, and sir has informed about the internships and all, which will be very much useful for your students. So, I request you to ask base of that, and as well as if any other queries you have.
Yeah, I think one question is there in chat box. What is the research scope in serverless IoT architecture? Yes, there are tremendous works currently going on in this serverless IoT architecture. Main objective is to reduce the cost. Okay, costs. Of course, in cloud we already reduced the cost of normal operations because cloud has if you want to purchase a server, it is costing more. Comparatively, if you go for cloud, cloud providers are there, they can provide you the servers, right? So you are not worrying about the networking that are there, the management that are involved, the cooling that you want to offer for that server. Everything is taken care by them. We are just remotely connecting to that server. But in our case, especially in IoT, for several applications, you can notice that every some applications are like you want to collect the sensor values only every month, right? So these are the typical applications where you can think of serverless. So you need not dedicatedly provide the server on. Okay, you need not power on and spend your money. Rather, if you have configured it as a serverless environment, then only when it is used, like maybe monthly once your sensor is active, it is going to collect the data. You have periodically programmed. So then once when the sensor is sending the information to the storage device, the storage device is triggering the information, and because of that, now the server is powered on. Got it? So of course, serverless means it doesn't mean that there is no server for execution. Server will be there only when it is required. That is the idea. Of course, there are a number of research opportunities. I have discussed several challenges of that also. Every research work could go in that direction. Hardware, I think you have to think how, say for example, if you can design a new machine learning hardware that will predict and identify a good server. All these are different research works.
Rangarajan sir, hope your doubt has been got cleared by professor. So if any of the professors is having any doubt, you can post your queries in the chat box. If not, you have a provision for unmuting yourself. You can unmute yourself. You can put up your queries. So we should wait for another couple of minutes so that they can respond.
My dear participants, kindly ask your queries or questions in chat box, or else you can unmute yourself and ask our resource person. It will be more interactive. You can unmute yourself and ask our resource person, or else you can type your question in chat box.
Sir, we got one question from Selvi ma'am. Under question is few machine learning algorithms for automation industry.
Okay, machine learning algorithms for automation industry. It depends on the data set that are there. Of course, it's a fundamental question relating to data science, I think. Machine learning, normally, if it is image-based, image-oriented, like for example, if the data is having images and you want to do some analysis, there are a number of algorithms in line to that. Recently, like ResNet, convolutional neural networks and deep learning networks are very popular in that direction, especially for preventive maintenance and so on, right? One of my PhD student is working on that 3D printing, where he checks the faults of 3D printers using the images. So for that, we applied ResNet and convolutional neural networks, deep learning based. Other than that, if the data is just based on sensors, for example, one of the work what we did was air quality monitoring and predictions. So for that, since the data is comparatively less, we can periodically collect the data and we can do the predictions of air quality in a particular location based on the latitude, longitude. For that, you can use algorithms like random forest, which was quite giving good results. Of course, other machine learning algorithms also you could try, like support vector machines or something else. I think there are a number of machine learning algorithms. And data science is very popular. So we also have one MTech course for industrial people, data science. IoT is definitely going to create a change because not only that, for patenting. For example, you go for patent, you cannot just survive with normal software, right? We need hardware, right? So hardware plus software means the possibility is very easy for getting patents. And under our MSME scheme, there is a provision that if you have an approved patent, you can attract until 1 lakh rupees funding. So if you have a patent, right? What is the procedure for sending or applying a business idea? Is it possible to visit you? Yes, I think you are always welcome. Personally, I mean, personal visit is not possible now because of COVID, but you can always write to me and I would be happy to redirect to the teams, appropriate teams. Okay, so AIC IIIT Kottayam as well as MSME IIIT Kottayam, these two incubation centers are becoming very active in terms of international collaborations also. So if some of your students are interested to move to Germany or Austria, you can also contact us. So our incubation center, through our incubation center, we will be able to support them. And I recommend you to become a nodal center, apply for nodal center of AIC IIIT Kottayam, our incubation center, so that there are several provisions. We always keep informing them about the schemes that are available, how the faculties can apply for the funding opportunities. But time to time, the schemes will change. There are talks and discussions and so on. So depending on different schemes, you will get several provisions.
Yes, sir.
So I think we are very clarified with your lucid presentation, sir, and your voice is also very feeble. We are very happy to have you with us, sir.
Let me, thank you. Thank the administration of your institute, the HOD, Dr. Sandhya Madam, then you also for hosting me, the present. I mean, the talk was hopefully good to you, and I expect most of you to get connected. This is
Yeah.
the forum where we can get connected and do a lot of things. Of course, this kind of activity will help help to move for that knowledge development for the growth of the country. Collectively, we could do a lot of things.
So
Thank
let
you
me
so much.
conclude the session with a formal vote of thanks. So that we
Okay.
should move on to the session. So, I'm Mr. S. Hariharan, Assistant Professor, Department of Electronics and Communication Engineering, Knowledge Institute of Technology. Is feeling much privileged to deliver a vote of thanks for our today's resource person, Dr. Shajulin Benedict, and thank you so much for happening to us as a resource person for this ATAL sponsored IoT, ATAL sponsored FTP on IoT applications, paradigms, and principles, sir. And we are expecting your presence in the future slots as well and future sessions as well. Physically, if we plan any, sir. So you have to accept our invitation for being present physically in to our institution. So thank you so much for accepting our invitation for meeting virtually, sir. Thank you so much. You have given more information about what is IoT and insights of IoT, and you have shared your experience as well. And thank you so much for your participation in this FTP. So thank you so much.
Thank you.
Thank you, sir. And my dear participants. If you have any queries, you can post your queries in the chat box, or you can write to sir. Sir will reply to your mail. And we have posted the feedback link on in the chat box. I request all of you to fill in the feedback form without fail. Since that is going to act as your attendance, I request all of you to fill in the feedback form without fail. Thank you. If you have any problem with filling the feedback form, you can ask me so that I can reply to your queries. And dear professors, don't worry, we will be sharing the feedback form on in the WhatsApp group as well. So with this note, we are signing off. I request all of you to join back at 11:25 a.m. for the next session. Thank you so much. Thank you so much for your active listening in the first session. Thank you so much.